Okay, so like I promised in the notes, these are the pressure and temperature warm-ups. There's actually only going to be two for each type. If you need more than that, get a hold of me either by emailing me or Snapchatting me, and I'll see if I can get together some more warm-ups. But I think you guys should be okay since these are pretty easy conversions. Okay, so the first problem is, what is the pressure in kPa of an object that has a pressure of 856 millimeters of mercury? If that object has a temperature of negative 15 degrees Celsius, what is the temperature in Kelvin? So there's two different conversions we're going to do here. So at this point in time, I want you to stop the video, try to do this on your own, and then start it back up and then look to see what I do and make sure your answers match. I'll go ahead and put the answers up first, and then I'll work out the problems. Okay, so the answers to the first one. So you've got 114.1 kPa and 258K. So if you got those two answers, go ahead and fast forward the video a little bit till you get to the next question. If you did not, I'm going to go ahead and work the problems out for you. Okay, so the first thing we're going to need is a conversion factor. So we're looking at, oops, hang on, kPa and mmHg. So we're going to do 760 mmHg equals 101.3 kPa. And guys, the order doesn't matter. Whichever order you put them in doesn't matter. As long as you have, that's the conversion factor. Okay, so let's go ahead and do it. We're going to start with 856 millimeters of mercury. And since that's on top, I'm going to put the 760 millimeters of mercury on bottom because I need to cancel out the millimeters of mercury, and the 101.3 kPa on top. Okay, and that's when you multiply 856 times 101.3 divided by 760, and you get 114.1 kPa. Okay, now let's do the temperature. Move this up a little bit, so give me some room. Okay, so I've got Celsius and I want to do Kelvin. So if you remember from the equation, Kelvin is you take the degrees Celsius and then you add 273. So we're going to take minus 15 plus 273. And when I do that, I get 258 Kelvin. Okay, so those are the two answers. So hopefully you got them. If you still have questions after you do the next one, then get a hold of me either through email or Snapchat or even the Facebook Messenger. I don't care, as long as you get a hold of me, and I'll try and help you. Okay. Okay, for this one, an object has a pressure of 0.954 atmospheres and a temperature of 345 Kelvin. What is this object's pressure in PSI and its temperature in degrees Celsius? So at this point in time, I want you to stop the video, try to do this on your own, and then I'll put the answers up first. And if you still don't understand why I got the answers I did, then go ahead and watch the rest of the video on how to do it. Okay, so the answers for this one is 14.0 PSI and 72 degrees Celsius. Okay, so to work this one out, once again, we do need a conversion factor. So I have PSI and atmospheres. So I know 1.00 atmospheres is equal to 14.7 PSI. So that's the conversion factor I'm going to use in this problem. So 0.954 atmospheres is what we're given. So I'm going to put the 1 atmosphere on bottom and the 14.7 PSI on top. It's going to cancel my atmospheres. And then I'm going to take 0.954 times 14.7 divided by 1. And that's why I get 14.0 PSI. Okay, now let's do the temperature. Pull this up a little bit. Okay, now this time I'm looking for degrees Celsius. So if you look at your equation, it's the Kelvin minus 273. So 345 minus 273, and that's where I get 72 degrees Celsius. Hopefully you guys understand this. If you don't, as I said, just give me a buzz. either by emailing me, Snapchatting me, or using Facebook Messenger if you're a Facebook friend of mine. Otherwise, emailing me and Snapchatting are probably the best ways to do it because I can answer those. Okay. So have fun with the practice problems. Bye.